Hi guys and welcome. It is now live. I have Dina standing next to me. It is Maths grade 10. Dina, how are you?
Very well, thank you, and ready for a jam-packed session this afternoon.
Fantastic. So good to see you. It's the first time I'm seeing you this year. This is the second maths session of the year, and I hope that all the grade 10s are tuning in.
Yeah, tune in, grade 10s, we're waiting for you.
You better be. And today we're going over algebraic expressions, fractions, right?
Yes. We're going to look at multiplication and division of fractions, as well as addition and subtraction. But before we do that, we're going to take a quick recap of what you did last week, which was the factorizing of expressions.
Fantastic. So go and to your little spot while I give them a little bit of a talk. Okay, guys, got a little bit of housekeeping to do. Join us on facebook.com/learnextra. Post all of your questions onto our page, Mindsetters. Don't forget that this community is not just for us, it is for you guys too. So help each other out, post your questions, and Dina and I will help you with those towards the end of the show. Of course, you can stand. Perfect. So now, I just want to let you know that things are hotting up with the presenters, guys. At 7 p.m. tonight, we are closing the presenter search, and the top 10 that you have voted for on our Facebook page will be going through to the next round for our new social media presenters. So make sure that you check out that album. I will post the link up again and get those likes coming in. And don't forget, tell all the matrics you know, or anyone that's writing SUPs, that we do have SUPs on in the morning, so they better be tuning in to learn more and learn extra. Okay, Dina, you ready for this? Let's go.
Yes, we're ready. It's good to be able to talk about fractions. It's one of those words that when people often hear it, they cringe at the hearing that word, because a lot have had many negative experiences. But it shouldn't be that way. I think that fractions aren't the evil monster that people make it out to be. It is quite simple if we know how to treat it according to the rules, as all maths gets done. There are some standardized rules, and we need to learn those before we can actually jump into it. So hopefully this afternoon we'll demystify all about algebraic fractions, and we'll get you grade 10s ready to jump in and take this through to grade 11, because you'll find that algebraic fractions are one of those key foundations that you will utilize again, not only in grade 11, but when you get to grade 12 calculus as well. You cannot differentiate when you get there if you cannot work with fractions. So it certainly is one of the building blocks. So let's get right to it. As I said earlier, we're going to first of all look at a little bit of the factorizing, because it does impact as a foundation piece into your algebraic fractions. So I'm going to start off with by recapping from last week's show. Okay. Let's go back there. Okay, so in this lesson, we are going to revise how to expand an algebraic expression by multiplication, and we're also going to revise how to factorize algebraic expressions, and we're going to then simplify algebraic fractions. Finding factors. Obviously, the factorizing is always known as the reverse operation of expanding or finding the products. There are different patterns that you can look for when finding factors, and we really do look at 4 types of patterns. You may have in grade 9 already seen that there were 3 that you worked with, and in grade 10 we've certainly added in the cubes. So the 4 main patterns that you get would always be, I want to look to see if that expression has perhaps got a common factor. After that, you're looking to see, could it be a trinomial, or could it be a binomial that is a very specialized one, which is the difference of squares. And then finally, you'd be looking to see if you've got the sum or the difference of cubes. Remember that the sum of squares does not have factors. And perhaps at this stage you may be asking, why all this fuss about factorizing? And you'll see in a moment how we utilize the factorizing as one of our tools in order to be able to work with the simplification of fractions. And also later on, any division that you do, whether you're in trigonometry or any of the other topics, division can only be done when we have one term divided by one term. And in mathematics, when you get things to one term, it's known as factorizing. So we're trying to extract all those factors that that expression might have, so it gets rewritten as one term. So we're getting everything to look into a format that has got one term. Okay, so as I was saying, the first one would be to remove a common factor from the expression, and in this expression, for example, we've got 5x squared plus 10yx, and if we took out the 5x as a common factor, we'd then be left with a binomial. And you'll notice how we have one term. We took two terms and we've made it into one. Then we've got the difference of squares, which is a very specialized binomial, and that simply has the two squares that have got a negative in it. And again, they're two terms that we've made into one term. So again, here's my one term, and it's a compound term. Then you have your trinomials. And a trinomial will have three terms, hence the word tri. And we've got a squared plus 2a plus 1 that can be factorized into the product of two binomials. Again, that's one term, and we could write it just as a plus 1 squared. Then we can get, so out of the three, we would always start off with to see if the expression has got a common factor, and then we would see, could it be a difference of squares or a trinomial? So we've got those three. And then in grade 10, you've also looked at the sum of cubes. And in that one, I'm also going to add the difference of two cubes. So when factorizing cubes, let's just go through that. You would take the cube root of the first term, and you would slot it in there. And you would take the cube root of the second term, and you'd slot it into that binomial. So your first bracket would always have the cube roots of both of those. And then the second bracket is made up of the square of the first term. So you square the first one, there it is. You square the last one, there it is. And this middle term here is made up of the product of those two with the additive inverse. So if you take that quadratic bracket and you multiply it by this linear, you're going to get the sum of two cubes. What would we do with the difference? It would be exactly the same. Instead of having the sum of cubes and having the sum in the first bracket, you would actually have the negative. But squaring this one, squaring that one, and taking the product and changing the sign would be exactly the same in both cases. So we then see if we have the cube root of x cubed would be x, cube root of negative 27 would be negative 3, and then this one is the first one squared, this term here is that one squared, and this middle term here is the product of those two. X times negative 3 is negative 3x, but then you change the sign. So there's a little bit of procedure being handled over here in terms of how that second bracket gets formulated. Just to go through that again, if we had, for example, and x cubed minus 8, then we would get cube root of the first, cube root of the second, and then how do we get the second bracket? You'd multiply it by the first one squared, multiply and change sign, so it would be plus 2x, and then plus 4. Okay, so that would be the cubes. Right, let's see. Now let's go and tackle some questions that deal with that, with revising those four, actually 5, if you want to call the sum and difference of cubes into two different ones. But really it's the 4 basic units or the tools that we use to factorize. First rule is always to analyze and to ask yourself, have I got a common factor? And if I do, then I'm going to remove that common factor. And remember that to take out a common factor, to remove a common factor, simply is the inverse of what I was doing if I'd multiply by using the distributive law. So I would be dividing by that factor. And then mentally, you should be multiplying back to see if you'd get back to the original. So we've got, first question is to factorize this expression. And I would always ask that you would analyze and talk to yourself in terms of what you're seeing. I'm seeing a polynomial. There are 4 terms. And my job, when I see the word factorize, is to get the expression into one term. So my whole job is to find one term out of those 4. And before we jump in, it's not a trinomial, it's not the difference of squares because I've got 4 terms. So therefore has to be, and there's no cubes there, so it has to be a common factor that exists there. So if we look at it carefully, out of the 4, we notice that this x squared and this term here, they both have got an x in them. And we also notice that this one and that one have got an a in them. So we're going to factorize by grouping, by taking out the x, and we are left with, what are we left with? If you take out x, what you're saying is x squared divided by x gives me x, and negative 2x divided by x gives me negative 2. Now, young grade 10s, you are budding mathematicians. You cannot just, mathematics isn't done just one direction, one route. You need to always verify that what you're doing is in fact correct. So accuracy is paramount. And in order to check our work, if we've just divided, we can now check by multiplying. So if we tested x times x, we do get x squared, and x times negative 2 is negative 2x. And factorizing is one of those topics in maths that you can check your work. You can verify your accuracy by just going to check that what you've done is actually correct. You don't have to wait for somebody to tell you whether you're right or not. You know by your checking mechanisms that it's correct. So it's basically almost like an accounting tool that you can have, like a balance or a journal that you can actually check. These things balance, they match, they make sense to me. With the yellows, what is that's a common factor? Would you say that the common factor is a, and then I'm left with minus x plus 2? Would you say that that's correct? Okay, no, that is not correct, because these 4 terms don't give me one term. I've now got that as one term. What I've done is I've isolated the 2 blue terms to give me one term, and I'm getting those 2 into one term. So there is a missing sign over here. Okay? And in mathematics, very often, you're trying to say something, and you'll write statements like this, and then you won't go anywhere because there's a breakdown. So if I have 4 terms, you've broken it into 2, I have to see a sign that separates those 2. It's not a times sign that separates these 2, it's actually a positive sign. So I could take this out as an A, but then I have to have a plus A. I've taken out a plus A. So I've got a plus A that I've taken out. What does it mean? Divide by A, so negative AX divided by A gives me X, actually minus X, and 2A divided by A gives me 2. Okay. Now, if you take out that positive A, you get left with this yellow bracket, which in terms of variable and number look identical, except for a sign. So if you look at this one, that's a negative x, that's a positive x, that's a positive 2, that's a negative 2. In mathematics, when 2 brackets have the same variable and same numbers, but they are different in terms of signs, we know we can take out a common sign. So therefore, we can say that if I have an x times an x minus 2, and I take out a negative 1 as a common factor, then I've got an x minus 2. In that way, I've now made, let's use this one. I've got this x minus 2 as now a common factor. So factors can be numbers, variables, and brackets. They can operate in 3 different ways. So if I take out this x minus 2, and that becomes our common factor, x minus 2 as a common factor, I'm now left with what? Out came the x minus 2, so I'm dividing by x minus 2 goes in there once, I'm left with x, and I've taken out the x minus 2. I'm dividing by x minus 2, so I'm left with a. Right, so that's my common factor. Then we can factorize a trinomial, but I'm going to make it easier for myself, and I'm going to say, hang on, I can see that 3 is a common factor. So if I take out 3, I'm left with 2x squared minus 5x minus 3. And that trinomial now can go into 2 brackets. The first term is 2x times x. The last term is 3, so 3 and 1. And if you look at your inners and your outers, I'm getting a 3 and a 2, and that's not going to give me 5. So I need to just edit that slightly and say that doesn't work because I need to get a 3 and a 1. So now I've got negative 6 and I've got positive 1. So I've now got the factors. And if I check, negative 6 plus 1 is negative 5, and 1 times negative 3 is negative 3. Can you see how you can verify your work and you can check it out? And then this.
Dina, let's take a little break.
Perfect.
Yes, okay. Guys, time for a break. I need to tell you something very important. You need to go and visit our website, and the website address is www.mindset.co.za/learn/extra/live. I'm going to post that onto Facebook and on Twitter, and what's going to happen when you get there, guys, it's so exciting and important. There we have our entire schedule, and not only do we have our schedule, you'll have a look there, you'll be able to see show notes. Click on the show notes and you'll be able to download grade 10 show notes for this very show. And in a few days' time, we will have this video up next to the notes so you can keep going back. So next week, when you feel like going to have a look at this week's show, you can go and find everything you need there. So go get yourself a glass of water, and we'll see you now after the break. Hi guys, and welcome back to the show, grade 10s, that I hope you are having a fantastic time learning more and learning extra. If you have any questions for Dina, please post them on our Facebook page, and that's facebook.com/learnextra. If you have any questions, if you need any links and you can't find anything, please post them there, and I will make sure that I direct you to the place that you need to be. Also, I need to know, well, I'm looking for people, content developers, people that develop content. We are looking for you. We need your content. So please email us content@mindset.co.za. Tell your teachers, tell your parents. Maybe they may know somebody that will be able to help us. Also, don't forget, guys, during the mornings there is supplementary school for all of you guys that are rewriting. So tell everyone you know to join in to 319. We are here to help. And also, the presenter search is nearly done at 7 p.m., guys. Even grade 10s, please tune in at 7 p.m. to see what the final outcome is. So keep your eyes peeled to the page and peeled to 319. I think, Dina, it's time to carry on with the lesson. Take it away.
Thanks, Indiana. And we right back to fractions. I'm going to just merge the cubes together with the fractions because there are 3 types of examples I want to deal with you for the next section. The first one is how to multiply fractions, algebraic fractions, that is. The second one is the division of fractions, and the last one is adding and subtraction of fractions. Now, everything you learned about fractions in primary school is still true. These things have not changed mysteriously. The rules that you've learned around multiplication, addition, etc., are very true still for algebra. But instead of dealing with numbers only, you're dealing with variables, you're dealing with brackets, you're dealing with compound terms, polynomials within those fractions. So things just get more exciting, but the principles remain the same. So for example, when you learnt about multiplying fractions in primary school, the first step in any algebraic fraction problem is to always identify all the factors of the denominators and numerators. And therefore, you must factorize to simplify the problems. So the real key or the real essence of being able to work with fractions is how good is your factorizing. So if the factorizing isn't in place, we're going to have huge problems with the fractions. So the first one that we're going to look at is a multiplication rule. And you can multiply, when we're simplifying fractions, we can multiply the numerator by the numerator, denominator by the denominator, and we would actually suggest that if you were going to do this, you're going to get these very bulky polynomial expressions. So I wouldn't actually do that. We would actually multiply and divide by looking at the factors. So that's where we're going to go to. Can we factorize? So if we look at our example, we've got a fraction with a binomial and a trinomial multiplied by binomial, trinomial. And if we had to multiply this out, we'd be sitting with a polynomial to the power of 4, and the bottom we'd also be left with a polynomial to the power of 4. So, and there we would be stranded. We couldn't simplify that any further. So what we'd like to do is to be able to factorize these expressions so we can see if division can happen along the way to make things simpler. Okay? So if we look at very quickly the numerator over here, you'll notice that it's a cube and 27 is a cube and so is 8 a cube. So I notice that this is the sum of cubes. We notice this is a square and 1 is a square, so there's the difference of squares. Over here we've got a nice trinomial hanging around, and over here we've got 4x squared minus 6x plus 9, and I wonder if that's factorizable. Okay, so my next question is to ask, would I be able to divide this negative 3 into this 27? Is it possible to say 3 goes into itself once and it goes into 27 3 times? And I'd really love to hear your answers, because if you can understand whether that is allowed or not allowed, you'll be able to really, really get full marks for these questions, because everything hinges on when can I divide and when can I not divide, and why can I not divide? So you can post your answers. Is it possible to divide or is it not possible to divide? Okay. And writing a fraction in this way is a way of making it easier for us to read. But if I had to write it horizontally, so if I had to write this expression horizontally, I would go 8x cubed plus 27. Then I would divide this by 2x squared plus x minus 3. So my next question is, would you divide the 3 into 27 if you saw it written horizontally? No, if you wrote it horizontally, you would want to find out how much is this, and then you want to find out how much that is, and then you want to divide the 2, because BODMAS forces us to do what's in the brackets first. Now, when you write it vertically, we say that implicit in writing it vertically is the understanding that they're brackets already. The brackets have to be there for horizontal division. If I write it vertically, they are there, but I don't need to write them there because that division line divides the two binomials. Problem is, people fall into the trap because they see a 3 and they see a 27, they say 3 must go into 27 9 times. Okay, and that's problem number 1. The biggest problem, and you can go and talk to your class tomorrow about it, is that they don't understand that this belongs together. So this expression over here cannot be separated into parts. It belongs together with a big bracket. And so the moment your friends begin to understand that that belongs together, then you would never, ever create that problem again with that division. Because the number 1 problem is that we don't know when things belong together. So I have a very little way actually a little way of doing this, and that is to say I cannot divide. So I cannot divide and we are getting a very strange. So we cannot divide unless we have one term, okay, and this is unless, over one term. So, grade 10s, if you, and anybody else watching for that matter, if I look at the numerator, I have two terms. So if I have two terms, I'm forced to get it to one term first. I've got two terms, forced to get to one. Three terms, forced to get to one, and three terms, forced to get to one. Otherwise, I'm going to break this rule that says I cannot divide because there's a bracket around the numerator and denominator. So there is not yet a one-termed expression. So let's go and do that. Let's go and factorize that. So we have the sum of two cubes, which would be 2x plus 3. And the second bracket would be, we said earlier, square the first, square the last, multiply and change sign. So it's 4x squared minus 6x plus 9. And we're dividing that by. There's a trinomial over here, so I'm going to try and factorize it. The first term is easy because it's got to be 2x times x. There's nothing else that will multiply to give us 2x squared. The last one is also easy because it's got to be a 3 and a 1. And now we need to get a positive 1. So 3 minus 2 will give us that. Okay? And then we have, oh, can you see something interesting? Ah, this bracket here is exactly the same as that denominator. So we actually don't need to factorize that denominator because we've actually got it as a factor. Can you see it's a factor? Anything that's connected to something else by a multiplication automatically is known as a factor. And therefore I can divide. So if I don't have one term and if I don't have factors, I cannot divide. Otherwise I'm breaking the BODMAS rule. Otherwise I can. So we now have this denominator over here that I'm multiplying by. So I've got a 4x squared minus a 6x plus 9. And then I have plus 9. This x squared minus 1, x squared minus 1, which, what are the factors of that? X minus 1 times x plus 1. So that's that numerator there. We've got an x minus 1, and we've got an x plus 1. And now we've got bracket times bracket times bracket times bracket divided by bracket times bracket times bracket. So we've got all these times, all these factors, and once we've got one term, we can now divide. So analyzing a question, you first need to know how many terms can I divide. If I can't, get it to one term and then divide. So what are the factors that can divide? We've got this 2x plus 3 can go into this x plus 3 once. Divide this x minus 1 into that x minus 1. Divide this trinomial into that trinomial. And we are left with x plus 1 as the quotient or as a simplification. So basically earlier where we said if we multiply that we'd get an x to the power of 4 and that to the x to the power of 4, guess what we've been able to do with factors? We've been able to get it down to x plus 1. Quite amazing. Okay. Right, so if we keep going, we've got the multiplication. Okay, so we can carry on and we can look on division. Now, division and multiplication are cousin operations, so what works for multiplication also works for division, okay? But we've got that very important rule of what does division by a divisor really mean in mathematics. So the meaning of division dividing by a divisor, okay, is the same as, okay, what is the same as? Multiplying by the reciprocal of the divisor. So we've really got, if I see a division sign and I have a divisor after that, then that's the same as multiplying by the reciprocal. So we switch the places of numerator and denominator, that's its reciprocal. For example, a half is the reciprocal of 2 because we've switched the numerator and denominator. And what happens when we take the reciprocal and we multiply it by a number is that that product is 1. Let's take a half and 2. If you multiply a half and 2 together, you get 1. And there are many places in mathematics where we need to get that reciprocal to help us out. And so we need to know the product of the 2 always will give us 1. In fact, the reciprocal is known as the multiplicative identity as well. But yeah, that's just by the by. Okay, so if we take the 4x squared minus 8x, what is the common factor? That's going to be 4x, and we're left with 2x minus 4. And then we've got this 12x cubed in the denominator. And if division is the same as multiplying by the reciprocal, we're now going to find the reciprocal as numerator becomes 9x and denominator becomes x minus 2. Okay. And let's just correct our little algebra over here. This should be a, can you see, 4 times 4 is 16. When I glanced up here, I saw 4 4s doesn't give me 8. So I know I've made an accuracy error. So that should have been, where are we today? Not in this planet. None of this is correct. Let's take 4x squared divided by 4x goes in once. So we're only left with x. And 8 divided by 4 is 2. So it's minus 2. And we now can divide. So let's divide. I'm going to divide in a different color. We're going to divide x times x into x cubed. So we're left with an x squared. We have 4 goes into itself once and into 12 3 times. 3 goes into itself once and into 9 3 times. And then we have got this x minus 2 goes into x minus 2. So we're left with a 3 over x squared. So same procedure as before. We factorize wherever we can. And then we've got this multiplication. So we've got one term across the numerator, one term across the denominator, and we can divide. Remember multiplication and division? We can do it simultaneously because BODMAS says multiplication and division are done at the same time. So the factors help us to bring it into a format that we can then divide the common factors. So that would be the division. I think, Indiana, we must take a break because I'd like to do addition afterwards.
Okay, fantastic, guys. Let's take a little break. If you do have any questions for Dina, please post them on the page and we will go through them because there's no such thing as a silly question, only the one that is asked after the exam. So please post them onto our page, facebook.com/learn extra, and we'll see you now after the break. Hi guys, and welcome back. Okay, guys, this is a very important section. So if you're not understanding, please post onto our page. Let us know where you're getting stuck, where we can help you. And also remember that this session that is live on TV now will be uploaded to YouTube in the next 3 days. So you will be able to go back, have the show notes, and work through it again, and keep posting on our page and let us know if you're not understanding. I mean, Dina, this is something that they're going to be doing from grade 10 to 12, right?
Correct, and beyond.
Yeah, so it's very, very important for them to ask all the questions now that they're not understanding. And Dina's going to go quite pace because it's quite important to get it now. But like I said, post those questions on our page. That's facebook.com /learn extra. Also, mindsets, if you would like to email us, it is helpdesk@learnextra.co.za. You can also chat to us on Twitter @learnextra. So there's many ways you can talk to us, and you can talk to us on all of them, but just let us know where you're stuck and how we can help. And also, mindsets, if you see somebody out there that's struggling with something and you can help them, please do. And I've seen that happening on the page already today, and big up to you guys that have been helping out so far. So Dina, I think we are going into the last 20 minutes of our show, so let's pack it in.
Thanks, Indiana. Well, yes, when you were in primary school, you learned about 4 operations: addition, subtraction, multiplication, division. And here we are in grade 10, and we're still working with the same 4 operations. Well, nothing changes, except the way the numerators and denominators look. They kind of get quite big and large, and at times they look monstrous. But remember what I said earlier, the principle that you learned way back in primary school still remains the same. So, how many of you remember how you would add halves and fifths? Do you remember that? If I had a fraction with halves and I had a fraction with fifths, what did you do? Well, that's when some of you began to learn the language of lowest common denominator, which really just meant that you looked at your multiples of 2, you looked at your multiples of 5, and you said, which number is common to both? And you said 10 is common to both. And then if you go on, you would find that 20 is also common to both. And then you'd go along and find that 40 is also common to both, or even 30 is common to both. So between the multiples of 2 and 5, you have many options of a common number that both 2 and 5 can go into. And in order to add fractions, we don't want to go far down the list and find that special number. We want to work with the smallest one because it will reduce the arithmetic that we're working with. So, if we look at 2 and 5, what would be what we call the lowest common multiple? Now, because we're working with fractions, we are looking at the lowest common multiple of those 2 denominators. And that's why we call it the LCD. It's just the lowest common denominator between 2 fractions. But we're not really looking at the denominators alone. We're actually looking at the common multiples that those 2 numbers have got. And so I'm going to work with a fraction that works with halves and fifths to start off with. Let's have a look. Okay, so we're going to go straight on to the example. Here we've got a classic example of, we've got halves, x over 2, we've got fifths, x over 5, and then we've got that constant 3. Now, if you remember 3 as a whole number, 3 is actually 3 over 1. So we really are still adding in halves and fifths because we've got the other one as 1. And whatever we choose from the halves and fifths will also work with a denominator of 1. Right, so we've already spoken about what is the common multiple between 2 and 5. And we go down the list, 2, 4, 6, 8, 10. We've got 5, 10. So 10 is the number that both 2 and 5 can go into. And so we say that we can now write, let's see. All right, before we do that, it's 3 wholes, we've spoken about that, is that we'd like to write each of these fractions, x over 2, we'd like to write it as something over 10. We'd like to write the fifths as something over 10. And we'd like to write the whole as something over 10. Okay. So what must we do to halves to get it to tenths? We must multiply it by 5. But we say that whatever we multiply the denominator by, we also multiply by the numerator, because a number divided by itself is 1. And when you multiply something by 1, it doesn't change its value. So when we say we multiply both denominator and numerator by the same value, in essence, what we're doing is multiplying by 1. So we're not changing anything. So it's a very clever tool to help us to not change the value. Fifths, how do I get fifths to tenths? I would multiply by 2 numerator, denominator. And wholes, how do I get them to tenths? I would multiply by 10, both numerator and denominator. So that's what's going to happen in our next step. We would get, just take this out. There we go. And let's just select there. There we go. Okay, so we're saying, how do I get my halves to tenths? Multiply by 5 divided by 5, which is my 1. How do I get fifths to tenths? Multiply by 2, numerator, denominator. How do I get ones to 10? Multiply numerator and denominator by 1. So I've got this 1, 1, 1, and I'm not changing the amount that I'm starting off with. Right, so if we do that, we now get, we've got x times 5 is 5x over 10, x times 2 is 2x over 10, and 3 times 10 is 10. And our purpose to start off with was that we were getting the same denominator. Why do we do that? Why do we want the same denominator? Well, it's a simple thing, is that if your denominators are different, then the sizes of your fraction are different. And we cannot add unlike sizes. I can't add a half and a quarter together because my half is much bigger than a quarter. So what I'm really doing is I'm saying, how can you write a half? A half is the same as 2 quarters. Now that I've got 2 out of the 4 and I've got 3 out of the 4, I can now add up the quarters. I'm going to get 5 of that size piece of whatever you were working with. So it's very important with fractions that when you're adding and you're subtracting, you need to add in like portions. And what tells us what that portion is that denominator. So if I'm adding in tenths, they are equal sized portions. I only need to work with the numerator now. So my numerator is 5x minus 2x plus 30. So I land up with a fraction out of tenths because now I'm adding in the same kind of portions, and I've now got 3x plus 10. Okay. What happens? So that was a very quick mix of primary school and high school fractions. Same principle, common denominator means the common multiple between the two numbers. If you find a bigger one, is there a problem? No, there's no problem. You can work with any number that's common. But you are going to find yourself creating this bulky arithmetic. And so hence we try and keep things to its simplest form. What's going to happen is you're going to have a common factor later on in your fraction. Okay, so don't get too worried about that common multiple as long as you find one that's common to both numbers. Right, but now what happens when we have variables? How does this work? How do I find the common denominator when I've got variables? Well, in the numbers, we always do the same thing. It's a common multiple. The variables, we find the highest power of that variable. That will be our common denominator. It's an easy way to find it. So if we've got x's and x squareds, then it's obvious that x squared is bigger than x, and that x can go into x squared, and x squared can go into x squared. So hence, x squared becomes our common denominator. So we look for the highest power of that denominator. That becomes our denominator. Now, you could say, if I've got x and x squared, why not make it x cubed? Remember, there are many, there are an infinite number of common denominators. But for us to have reduced amounts of algebra to work with, we would like to work with the highest power of the given denominators. Right, so let's have a look at our example. We've got 2x squared y, 4x squared y squared, and 6x. Deal with one thing at a time. Let's deal with the coefficients first. So we've got a 2, 4, 6. 2, 4, 6. What is the common multiple between 2, 4, 6? It's not 2, it's not 4, it's not 6. If you are struggling to find it, then you can multiply all the numbers together. So it's 6, 4 is 24 times 2 is 48. So 48 will work. But I would say that if you look at the common multiples of 2, common multiples of 4, common multiples of 6, you'll be pretty sure that when you start off with the highest number with 6 and 12, what happens with 12 is that 4 has also got 12 and 2 has also got 12. So I think let's work with 12. Can you see how much easier it is to work with 12 than 48? Okay? And then we said every variable, every single variable, or every single bracket that you find has got to have the highest power. So let's look at x. I've got an x squared here, I've got an x there, and I've got an x there. Do you agree that x squared is the highest power? So we will fetch that for our common denominator. And then y squared is also the highest power. So those denominators that I'm going to now have, let's just see. Okay, so I'm going to have this fraction here as something over 12 x squared y squared. I'm going to have this fraction as 12 x squared y squared in the denominator. Okay, we'll get to the next two just now. So we've got, this one's gone from 2 to 12. So what's it missing? It's missing a 6, and it's gone from x squared to x squared, so it's missing nothing over here, and it's missing a y, because that denominator's got a y squared. So I'm going to multiply this denominator and numerator by 6x, no, not x, we don't have any x there, we've got a 6y, that's what it's missing, 6y, 6y. Okay, now as grade 10s, we are really grooming you for grade 12, and you must be able to do some mental arithmetic or some mental algebra as you go along. We don't need to write the 6y over 6y because we are having a look. If you just use your fingers, you go from 2 to 12, so you've got to multiply that by 6, and you're going from y to y squared, so you've got to multiply it by y. And then you can just write the numerator as 6y, because when you get down to the next step, there's my 12x squared y squared, and where am I get 18y from? Because the 6y was missing from the denominator, so it's missing from the numerator as well. So you've got to be able to be flexible, quite flexible with that finding of that denominator and seeing what's missing. Remember that what's missing is what you're going to be multiplying by. So with the 4 and the 12, there's a 3 missing, so 3 5s or 15. There's an x missing, so there's the x, and the y squares are there. With 6 and 12, 2 is missing, so you multiply 7 by 2. And x has only got one x, so there's an x missing, so there he is. And there's a y squared missing. Then 4 is always written as a 1. So this is 4 over 1. So the whole denominator has got to be multiplied by that 4, so it's minus 48 x squared y squared. So same principle. I've got to find the common denominator, and I've got to find what factor I need to multiply each denominator by in order to make it an equivalent fraction. And what I do to the denominator, I also do to the numerator in terms of multiplication. So I can now keep going. Right, so let's just go up a little bit. Okay, so I've now got y, x y squared. There's no like terms, so that's as far as I can go. I can't keep going any further. Okay. Right, so let's see. Let's get some questions going. How would we add these fractions? Look at it. What does it say? I've got halves, I've got thirds, I've got quarters. What am I doing with the fractions? Am I multiplying or am I adding? I'm adding and subtracting. So addition and subtraction, I need a common denominator. Multiplication and division, I don't. I factorize and I multiply and divide. So the tricky part about addition and subtraction is I need common denominators. The tricky part about multiplication and dividing is I need factors. So they are two separate things altogether. Okay, so we've got my common denominator, halves, thirds, and quarters. 12s will do. So 2 into 12 goes 6 times, so I've got 6x minus 6. 3 into 12 goes 4 times, so I've got 4x minus 8. 4 into 12 goes 3, so I've got minus 3x plus 9. All right, so we now have 6 and 4 is 10. 10 minus 3 is 7. And I've got minus 6 minus 8, or 9, is 1. And that is minus 5 over 12. So when everything is in 12ths, I can now add. Okay. What about the next one? What are we doing? Add, subtract, add. What do we do when we're adding fractions? Common denominator. What is our common denominator with variables? 4, 3, 2, 12. X squared, x cubed, x. Largest is x cubed. And we've got y. And now we can go and find the equivalent fractions for each of those numerators. Minus 3xy, 12 y, and we've got a plus 6x squared, and we can't add those either. Hope you enjoyed. See you soon.
Okay, grade 10s, that comes to the end of our show. Thank you so much for tuning in. Tune in same time, same place next week. Grade 11s, you are next, so don't you move. Grade 12s, obviously you're in for all of the sessions, right? Because that's how it should be. Join us on our Facebook page, facebook.com/learn extra. Post your questions. We are here to help you. This community is not just for us, it is for you too. Bye, grade 11s.